Thanks for the invitation. I appreciate it. You should be able to see my screen. Can you?
Yes, we can.
Oh, okay, good, good. And you can see me scroll?
Yes.
Oh, good. Okay. All right, good. All right. My name is John Boik. I am currently a contractor at Verces, also a research fellow at the Active Inference Institute and past SAB member there. And Carl was kind enough to invite me to give this talk after a couple of my papers just recently came out. So the topic is what I call the CogNarr ecosystem, and this is a online ecosystem of tools and services that is designed to facilitate group cognition at scale. And I should say that this is incipient. It's in my mind. It's in the two papers that I wrote, but it's not much else than that. So this is the birthing of a project. Hopefully it goes somewhere. Who knows? But I hope it does. Just a few. I've shared this PDF with Riddy, and I don't know if there's a way that PDFs get posted anywhere for the group, but just in case they do, these links are in the PDF. The first is to the CogNarr project page at the Active Inference Institute, a link to the calendar at the Active Inference Institute, and that calendar has a link for my biweekly meetings on the CogNarr project on Wednesdays, and anyone is welcome to join us and invited to join us. And then the three papers I have listed here are the first two are today's topic. They're about the CogNarr system. The first is a general CogNarr system facilitating group cognition at scale. Is a general paper that lays out the concept for the CogNarr ecosystem, and the second paper focuses in primarily on what might be an appropriate, asking the question, what might be an appropriate meaning representation for the CogNarr system, and I'll explain that more in a minute. And then the last link here is a link to the first in a three-part series I published a few years ago that is really the background for the CogNarr project. I'll talk about that in a minute too. All right, well, to begin, imagine that we all are in some kind of online group discussion. And maybe the topic, maybe we live in the same town, and the topic is how do we adjust our reservoir system to meet some particular need? And I have in my head some model of the way the world works, some belief system of what's connected to what and what affects what. And maybe this picture here is something that might be in my head. And maybe in your head is a different picture with, potentially different elements to it or different strengths of influences. You might recognize this as a causal loop diagram, often used kind of as a summary of an underlying systems dynamic model. But this picture I have in my head doesn't need to be a systems dynamic model. It could be anything. It could be maybe it's a different story, and it's maybe a murder happened and we're wondering who did it, and the picture, the model in my head is not at all a dynamical model. But the thing is, I have some belief system, some generative model in my mind, and you might have the same. And the question is, how could we share those transparently and in a way that is computationally feasible, so that if there's, say, 1 million of us in this meeting or in this group, how do we share our understandings of the world on some topics so that we can maybe discuss the differences and the similarities, and then hopefully come to some kind of shared agreement about the way this little chunk of the world works. So that's really what the CogNarr system is about. Here's a different way we might imagine some topic. This group question is, why is Max in the hospital? And this is a graph depiction. It's a discourse representation theory tree structure diagram for the sentence, Max fell, John might have pushed him. So maybe we are trying to solve a murder here and we're wondering what happened to Max. This is another, what I will call a meaning representation of how we might structure words to make sense to both a human and a computer. The discourse representation structures are actually very common meaning representation used in natural language processing and natural language learning. And there's some others that I'll cover in a minute. But what I want to impart to you just now as a beginner, as a start, is just that we might have different models in our head and we need some way to represent those models so that we can communicate them to each other. So towards shared explicit belief models, I belong to some group and I would like to share what I call a story, or you could call it a narrative, but it's really essentially a belief model. A generative model, probabilistic model about what happened, what might happen, how did it happen, what should we do, what does it mean, how does it work, or many other types of questions like this. And not only do I want to share the story, I want that story to be heard by the group. I want it to make some difference, not just be put in a bin somewhere. I want the group to understand what I'm saying because maybe what I'm saying is important. Maybe I have a rich story I want to share that is maybe lengthy or nuanced or conditional or something other than yes or no. Like like you might see a survey that says, do you believe blah blah blah? Yes, no. This is a much richer form of communication. And the group that I belong in might be a very large group, perhaps hundreds or thousands or even millions of people. How does a rich story get communicated to a group of, say, 100,000 people? Obviously, you can't write a story. Suppose that I was going to write down my belief model or my story, and suppose it was 20 pages. And suppose there was 100,000 people in this group. Well, 100,000 people are not going to read 100,000 20-page stories. That's just impossible. So however my story is communicated, it has to be done in some kind of fashion that a computer can understand, so it can digest and make sense of all of these potentially rich and nuanced stories. So that is the question for the CogNarr system. CogNarr means cognitive narrative. And right now it's just a concept, and the concept is for an open source online ecosystem of technologies, resources, libraries, tools to facilitate group cognition, and especially for large groups, and especially with regard to deliberation, strategizing, collaborative problem solving, and decision making. But having said that, there are many, many, many uses for this online system, and some are like customer service, for example. Maybe a company creates some widget and there's returns on the widget, and they would like to know, why are people returning this? What broke? What's the story of why this widget is being returned? So that's another example. So there's many, many examples. I'll cover a few more later. So CogNarr helps users tell their story, to convey their beliefs to a group about how the world works relative to some situation. And as I said, stories can be rich, potentially long, complex, nuanced, conditional, dynamic. Dynamic in the sense that if we're in a group together and we're trying to reach some kind of decision together, we might edit our stories in rounds, for example. So over a series of rounds, as we digest and discuss and understand how the similarities and differences and other characteristics of different stories, we might blend those belief models and end up with perhaps a shared belief model, or perhaps a few shared belief models. So there's a computational back end to this system that assists users in constructing stories, helps the group to digest and make sense of the stories submitted. For example, the differences and similarities, the characters and other aspects of stories, maybe the quality of the story. And it assesses stories for quality. Is the story on topic, complete, comprehensible, timely, things like that. And then also performs inference for both user and system generated queries. So maybe you put out a story, or you put out your belief system, and I don't understand it. I don't understand if, Tim is the brother of Bob or a cousin of Bob. I'm trying to figure out what's going on. Maybe I can just send a query. Maybe I can query your story directly, or maybe the system will query your story and say, hey, I don't understand this. What's the relationship here? As I talk too, I do keep in mind that this CogNarr project is, potentially large, enormous even, and complex. And there's no need to build, if this were to be built, there's no need to build an extremely complex ecosystem to start. The initial ecosystem could be actually quite simple, and as a minimal viable product. So as you listen to me, do keep in mind that the MVP could be relatively simple and straightforward. And also, I claim that this is all possible with today's technology, but obviously, as CogNarr evolves, as it becomes more powerful, then emerging technologies would be useful for it. So importantly, the system does not predict the future. So that's not the purpose of this. It's not that if our group is trying to solve some kind of reservoir problem, and we have a model of what the weather will be over the next year or two with rainfall and things like that. The purpose of this is not to have some model of reality that predicts what's going to happen. The purpose is to allow users to share their belief models. And a particular user might believe that it's going to be rainy over the next year, and we should manage the reservoirs in such and such a way. But another user might think something entirely different. So the main thing that CogNarr does is shares belief models and makes them explicit so that they can be digested by a large group. Likewise, the system does not assess the realism or accuracy of a story, and that is the role of the group, unless the system has special instructions to do so. So what is a CogNarr group? Really a group, I think of a group, and I think of a society actually too, as an organism that is performing some kind of cognition. And the CogNarr system is part of the cognitive architecture of the group or of the society, or whatever a degree of formality the group might be. A group could be a social club, a volunteer group, civic organization, corporation, nonprofit, political entities such as a city or state. Can be formal or informal, flexible or structured, temporary or permanent. So one can imagine just about any group, any group that needs to make decisions, any group that needs to digest information, shared information. One could imagine that group using a tool like this. So what is a large group? That could be, perhaps dozens. There's also applications of just a single user group. Just I'm going to use CogNarr myself to record my thoughts, or to maybe one day to play out a strategy. Like, here's what I believe is going on. What if I take this move? What if I do this? What if I do that? How might the rest of the world respond? Maybe in a very advanced CogNarr ecosystem that might be possible, but for now, the standard application I think of is this decision making and decision making in a large group. So could be hundreds, thousands, millions of people. That's the point of CogNarr, is to allow cognition, facilitate cognition in large groups. And it's supposed to facilitate functional versus dysfunctional group cognition. And that's partly where active inference comes in, as active inference as a description of cognition and group cognition, and potentially dysfunctional group cognition. How does a group know that their process that they're going through is functional or dysfunctional? What is cognition? And then I don't have to tell people here about active inference. Um, but I maybe just will highlight the last line, that the last bullet, that active inference potentially offers a description of functional versus dysfunctional cognition. I'm sure people might have more to say about that. So what is CogNarr? CogNarr is a cognitive architecture for the group. Cognitive architecture being the set of components by which and through which cognition occurs for a group. And this includes, for a group, this includes sets of norms, rules, mechanisms, and potentially institutions, tools, sensors, analytic processes. CogNarr doesn't have all of this, but in general, for group cognition, any of these things can be a part of it. Yeah. So as I said already, I think CogNarr provides a means to digitize and make explicit a person or an agent's belief model. The CogNarr ecosystem does fit in with previous work I've done. I have 3 papers linked here. This is a series of 3 papers that came out in the journal Sustainability in 2020 and 2021. And in that series, I'm also concerned about cognitive architecture. Only in the series, I'm looking at societal systems, that is, economic systems, governance systems, legal systems, financial systems, as a good portion of the cognitive architecture of a society. And then the question becomes, out of all conceivable designs for a cognitive architecture for societal systems, which ones might facilitate group cognition the best? So the series tackles a much broader problem, but I think an important problem. And the purpose of the series really was to try to get the science community interested in examining this, a society from this perspective, and to help the scientific community to imagine that we could do that together, in conjunction with civic groups and other groups. And in the series, I put out a path as to how that might be done in a efficient and reasonable process. So CogNarr, though, is, maybe you could think of it as just maybe one part of this larger societal cognition process. And maybe you could, my original thinking of CogNarr is that this one day it could be part of a governance system for a group, a new form of governance. But there's many other much more practical applications than being part of a governance system for CogNarr. So maybe the core innovation of CogNarr, or at least the center of CogNarr, is some kind of meaning representation. And I don't know if people here are familiar with the term meaning representation as it's used in natural language processing, but perhaps many of you are. Quite commonly, in fact, when in NLP studies and natural language understanding studies, a sentence will be converted into some kind of meaning representation that a computer can understand, and then inference and various kinds of calculations can be done on that meaning representation. So CogNarr has a meaning representation that I call a story graph, and it's constructed as this diagram shows. So I'm a user, I belong to a group, and I would like to tell my story. I start, if you can see my mouse, I don't know, but if I start at the top and I type in perhaps just some phrase or sentence, some short little description of some part of my larger belief model. I think reservoirs should be full, or whatever that first sentence might be. And each sentence gets added, gets translated into what I call a story graph fragment, just a small piece of a larger story graph. And then as the fragments are constructed, they are merged to produce a larger story graph. So again, the story graph is a representation of a person's belief model about some situation. And then once the story graph is constructed, and this could be a relatively complex story graph with multiple layers and other features, it could be translated then into probabilistic models, which could be active inference models or other types of models. And those models would be used to, for example, play the story forward, like according to this belief model, what kinds of outcomes are expected? What are, if this story were executed 1,000 times, what are the kinds of outcomes that we might expect to happen? Usually people have some degree of uncertainty about their beliefs about the future. So maybe I believe that it'll rain, 70% chance that it'll be a heavy year of rain for this reservoir or something like that. And my story about a reservoir could get constructed into some kind of probabilistic model, and that model could be played forward to find out the kinds of outcomes that I believe will happen. And a story graph could also be translated into other meaning representations that might be useful for other models, or even translated back into natural language so that I can, read back my story and make sure that the system understood what I intended by my story. So here's another example of a meaning representation. This one is AMR, a very popular one in the literature. And this is for the sentence, a similar technique is almost impossible to apply to other crops such as cotton, soybeans, and rice. But while AMR is quite, a common meaning representation, as I said, a story graph is much more complex than this and might involve layers and high dimensional vectors and much more than this. Here's another meaning representation called DiscoCirc. This is Bob Koch, if he pronounces his name that way, I'm not sure. But this one is kind of interesting. It also involves high dimensional tensors, but this is actually a computational graph of how those tensors would influence each other. So the tensor for Alice, it would be affected by the tensor for Sober in this little story. And then the combination of that would be affected by tensors for, see and dance and clumsily and drunk until you get to the bottom. So this kind of high dimensional approach might be quite appropriate for quantum computers. Maybe not so much non-quantum, but advances along these lines have been made that are appropriate for conventional computing. So this is just another way that a story could be represented. Someone's going to have to tell me when I'm going to run out of time, if I'm going to run out of time soon.
So sorry, I came in late and I would like to introduce myself now that I have the opportunity. I'm really sorry, I'm supposed to be chairing this meeting, but I was stuck out for some reason. And Carl very kindly helped me debug that issue and let me in. But yeah, you should have around 40 minutes in total. So assuming you started at 2:30, you would have around 7 minutes left. But yeah, it's not a strict deadline, so you can go a little bit above or a little bit below that as you wish, but not too long.
Okay. Okay, good. Well, if I start to go too long, just wave at me or something.
Yep.
We were waiting for about 10 to 15 minutes trying to get you to join us. So
okay.
Oh, you got loads of time in principle.
Yeah.
Okay, well,
okay.
just
Wonderful.
let me know
Thank
when
you.
I'm running short here. I am getting towards the end anyway. So just some use cases. How might this CogNarr system be used? So it could pertain to any kind of group, as I had mentioned before, and a group would perhaps send out an invitation to its mailing list and say, hey, we're holding this event and we're going to discuss the reservoir, and can you please join us? And as part of that, the group would outline what the topic is, what the purpose of the event is, how it's going to make decisions, what are its rules, and all kinds of things like that. But in general, for different use cases, communications can be many to many, as in the group decision making, could be many to one, or it could be one to many. Example use cases include decision making, as I said, customer service, emergency reports, public polling, instructions on how to build something, system descriptions, education, and many other use cases, potential use cases. And in saying that, I believe that if CogNarr were constructed and it was efficient and it worked as advertised, I would think that it could be ubiquitous. This kind of tool could become ubiquitous inside society, because societies need to make all kinds of decisions. Groups need to make, all kinds of groups need to make decisions about one thing or another. And when you compare the sophistication of CogNarr to other tools that are out there available today, CogNarr is just simply a far more sophisticated tool for group discussion and group cognition. I mean, it's designed with a scientific understanding of what cognition is, and it's just more sophisticated than anything else. So I think it could actually be an extremely useful tool if it were ever built. Later versions of CogNarr might even do more. They might include role playing and strategizing and other things like that. So here's one example. This is for maybe a city, perhaps, that wants to address some issue. This is group decision making. This person's story, just written in words, is to address this issue X, we must first address issue Y that caused X, and issue Y originated when blank and has the effect of blank. And if we don't solve Y, then we can't solve A, and and so on and so forth, for some kind of rich little story about what's going on and what should be done. And in that kind of setting for group decision making, the editing and the digestion of story graphs might actually go in rounds. You start with maybe an initial story. The system provides computations and assessments, and assesses similarities and differences and contents, and assesses stories in various ways and reports back to the group. The group digests the feedback the system is giving. There's opportunities to query graphs and get more information. And then the process continues again over a series of rounds until hopefully the group, their shared belief model becomes established by the group, or maybe possibly several conflicting shared beliefs model become established. Here's another example, an emergency report. I have worked in the past with utilities, and I have read some of the operator reports from calls that come in, and they are unimaginably bad, some of them. You don't even really understand what the operator is saying or what the person was trying to say on the phone, and many of them really are really poor at communicating rich, good information, solid information. But here's an example where somebody calls in or creates a graph that says, hey, I just witnessed an accident on some intersection. Looks like a large trunk, maybe a tanker, began swerving. The road was wet, but it shouldn't have been going so fast. And there's been many accidents there. The truck hit an electric pole, the wires started sparks in the grass, and there's a school nearby. So the children are potentially in danger here, but all of this is a little bit hard to see. I'm about a block away. So, you can imagine some relatively complex story that would require all sorts of inference to make sense of this. But that's just one example. Accident reports for a corporation are another example. So in the second paper, I've been sort of waving my hands so far and just saying that there's some meaning representation for the CogNarr system, but it's not clear at all yet to me what that meaning representation should be. And the second paper really is taking a deep dive as to looking at the various kinds of meaning representations that are used in natural language understanding, and kind of surveying them, and then from the survey, picking out a few that look particularly promising for the CogNarr system. And in that second paper, I provide a desiderata of at least 20 items, if not more, But from the way I'm thinking, this meaning representation ought to be graph-based, human-readable, amenable to computational inference, analysis, capable of handling document-length stories, and a wide variety of linguistic phenomena. I discussed the many kinds of phenomena that a CogNarr system would want to understand. The meaning representation should be reproducible so that similar stories produce similar graphs. It has to handle all sorts of metadata, fluid beliefs, beliefs about the beliefs of others, probabilistic predictions. It maybe should have layers, confer sets of nodes and edges with meaning. For example, maybe there's a collection of nodes that represents a bank or how a bank functions, something like that. And should be compositional, so you can tie these groups of nodes and edges together in some kind of meaningful way. And I think category theory, applied category theory, has a lot that could add to this effort. And the object, if say we have an object of a bank or something, those objects should be reusable by others, or an object of a reservoir, say. I won't go into the many ways that category theory might be used, but I think there's many. Mal has written on this a little bit for the way that shared beliefs might blend and form as a group shares their ideas. Functors for graph to graph, graph to text, and other kinds of transformations could be used from category theory and others. And the last slide is just a few ideas. A story graph really represents episodes or paths of a narrative as a graph that evolves over time. There's many opportunities for agent-based type models. A person understanding a group's beliefs, a group understanding a person's belief, the system understanding a person's belief, and the group's belief, and so on and so forth. Many opportunities for active inference models, and opportunities to use active inference in describing or assessing what functional versus dysfunctional cognition is. What is the quality of this particular cognitive process of this particular group, as well as describing issues of power, autonomy, sustainability, agency, and well-being. Mal, again, has written on several of these topics. So that is my whirlwind nutshell of what the CogNarr system is. And I welcome any questions and comments.
Well, first of all, thank you so much, John. If we can have everybody unmute and just give him a round of applause. Thank you so much. This is a very clear presentation and a very, very interesting tool that you're proposing as well. It brings to mind something that Simon Sinek says, who's like a influencer, CEO type of a guy. He says something along the lines of communication isn't about what you want to say, but about how the other person might hear what you're saying. So it is about that narrative being conveyed in a very clear manner, without considering, with consideration of other people's bias and how they might perceive that same piece of information. So I do personally have some questions myself, but I would like to open the floor to other attendees as well. So if you have any questions, then you can just simply unmute and ask away, or raise your hand and I'll call on you. Yes, Jerry.
Yeah, first, great presentation, John. Really enjoyed it. Second, I was just curious, have you done any application of this in a business setting, or tested it out at all for the purposes that you outlined?
No, as I said at the beginning, all of this is essentially all of CogNarr is what is written in the first two papers. The papers just came out several months ago, and as preprints. And, this is the beginning. But I imagine that there could be many applications within the business world, just as a just decision making within the business world, decision making within an executive team, even perhaps, or the more mundane things like, as I said, like customer returns center, call centers, accident reports. I could imagine many applications within the business world.
Yeah, no, absolutely. I once upon a time happened to be a insurance claims representative
There you
among
go.
things
Yeah,
in my life, so I could
yeah,
definitely see application for it there.
yeah.
I guess just as a quick follow up then, because I think that within the business world, and like my background is marketing. I was in insurance for a really long time, but marketing more specifically now is what kind of information gets passed up versus just generalized information. So within this structure, I'm just trying to think like how is there any thought around like the type of data that might be continuously passed? Because I think it's about, you know, not just information for information's sake, but like passing certain types of information that are relevant for the business operation, whether that be a cell within the business or whether that be all the way up to the top. I'm just thinking about like even how brains work and like passing up the hierarchy and down the hierarchy, that there need to
Right,
be some structure there, and just curious
right.
like if you've given thought to like how that might be structured versus just narrative for narrative's sake.
This is definitely not narrative for narrative's sake. This is purposeful communication for the purpose of group cognition, whatever that, whatever the group's aims are. And so a group could be, just a team, a work team, could be some larger element within a business setting, but they would probably only use this tool if they needed to cognate, as in the however that is, defined for them. So in an event, what I call an event, a group forming to address some topic, uh, the event could be a single moment event, is a single moment in time where we just get together once and that's it. We make a decision and we're done. Or it could be an ongoing process where we meet every 2 months or every 2 weeks, and this situation that we're facing is an ongoing situation that needs constant updating and constant refreshing, maybe constant decisions, and so there's the process that the group goes through can be quite varied. And what CogNarr does is provide the tools just to make that happen, to make that available. So whatever the group needs to do, whatever kind of group it is, whatever rules that group wants to use, maybe it's an autocratic group, or maybe it's a democratic group, or maybe it's as I said, a many to one or a one to many group. But whatever the group is, it sets out, it publishes what its process is, what kind of events these are going to be, what we're going to talk about, what the purpose is, whether this is a one-time shot or an ongoing shot, or whatever the situation is. Oh, and
Gotcha.
just related to that, maybe I should say too that I envision this CogNarr system as a open source project that has some kind of governance model that guides it. And the reason that I am really insistent that if it's developed open source, is because this kind of tool would be so amazingly powerful, and it would contain, imagine a repository of stories after 10 years, and these are the deep thoughts about how people think the world works, and rich communications, and you could even say that they are have been refined. Like I would like to tell my story and I want to tell it clearly. So I'm going to refine my story to not be ambiguous, maybe. So, curated, these are curated, self-curated stories, you might say. And the group helps to curate stories when they say, hey, I don't understand this part of your story. What does this mean? Or what does that mean? So we have these really rich stories about all kinds of domains and all kinds of humans' thinkings about different topics. And in the wrong hands, that would be potentially devastating to a society, I think. So I think it's important that this be developed open source and transparently, that its rules are transparent. But nevertheless, on top of that, some company could provide, extra, visualization layers or extra tools or extra gadgets that would, facilitate the underlying open source stack. So I think there are actually many business models that could be built into this as far as delivering products to industry. But the core system, I believe, would have to be open source. So it's not what you asked, but I went off on a tangent there.
No, I think it's actually an interesting tangent because there's a lot of discussion around institutional knowledge. So if I'm hearing you correctly, like that, history of stories and problem solving, if you will, would be some sort of institutional memory.
Could be, yes. Could be thought
Yeah.
of that way. And all of these would be edited, there would be an audit trail of how decisions were made for any group that was using this. So that audit trail could be useful, in many cases. If nothing else, just to look back and ask what was the quality of this process that this group went through.
Mm-hmm. Yeah, I mean, I think that could be in the history part of it. The audit could be interesting, both in terms of, what I think you're describing, which is problem solving in real time, but also then having that history of how previous problems were solved that could be queried. Because I do think that is
Yes.
Within organizations, a problem that many of them face is you lose somebody that has all that knowledge of how problems got solved.
That's true. Yeah.
Written down anywhere. They just did it.
Yeah. This would offer perhaps a record of some of them.
Yeah. So no, very interesting, and thank you for the additional detail there.
Yep.
Thank you, Jerry. Are there any other questions? Okay, I will ask mine, but please feel free to raise your hand up if you have any that come up. So just to go back to what I was kind of saying about how there is an other agent that's involved, how would you model that other agent? Because at least in active inference, how we're going about it is we create a copy of the main agent and then update the model of the other agent as we get more information and more observations about the other agent and learn about the other agent. And therefore we update the world model for the other agent. So then we can know how they would infer the same observation, which would be the language or the rich narrative that is conveyed. So do you have any ideas as to how that would work in this scenario?
I've in the broad design of CogNarr, I've tried to incorporate ideas from active inference. That is, the general concepts of what cognition is and how it happens and all that kind of stuff. And as far as what kind of specific models could occur what kind of specific active inference models could occur, there might be many ways. There would be many tasks that would have to be done in the CogNarr system. For example, the system might need to look at a person's story and then find out what is vague about the story, what part of this is not clear. You would want the system to be a little bit like a good listener. If you're telling a story to a friend, that friend maybe is a good listener and it's listening very closely and saying, well, I don't understand. Is that reservoir north of the second one or south of the second one, or whatever the question might be, trying to resolve ambiguity. So that's one potential application of active inference models, is the system trying to understand someone's stories. But then you have individuals trying to understand other individuals' stories, or individuals trying to understand where the group is going, or the group trying to understand what an individual story is. And so there's numerous computational tasks, many computational tasks, and each of them might be appropriate for an active inference model. But I haven't gotten so far along that path to say here's a specific specific active inference model that we could employ. So it's as I said, there's 2 introductory papers on this, and the rest remains to be done. But I think there could be some really interesting active inference models built for this, for the many tasks.
Yeah, certainly. I think it's a very intriguing problem to have and to resolve as well within the active inference community.
Yeah.
And also just predictive processing in general. And I think another thing that you mentioned that would be pertinent to the simulation that we're talking about, or just a use case, like a demo or a proof of concept of some sort, would be how the natural language is dissected into a story graph, and then how is that dissected into a factor graph? Because that's also one of the big open-ended questions that we currently have that's unresolved. There is a paper that I would like to share with you as well that might be worth reading. I can send you a link of this through Slack or something, but I'll just, okay, I can't share my screen. Okay, I'll just send it to you through Slack. But it is the belief sharing paper where the first author is Ozan Katal. And it's an IY publication that we have for the conference. So I'll just send it.
I think I have the paper, actually. I think I've read it before talking about the same.
Okay. Yeah.
Belief sharing, blessing or curse, or is that the title?
Yeah. Exactly that one. Because so I was involved in the project as well, and one of the problems that we had between communication, regarding communication between two agents, is when we just convey the probability distribution over beliefs, that's not really enough to understand how confident the other agent is with regard to that belief and where that inference is coming from. What actually worked was conveying the A tensor, so the likelihood probability distribution, and that provided a lot more rich information when that conversation was happening between the two agents. So yeah, it sets up why we had to do what we did, and just some scenarios where there was a bad bootstrap of like creating an echo chamber, for example, or some self-doubt. So yeah, I think that paper is worth a read, but as you said, you've already read it, so here's that. Also, another question that I have. Sorry.
Just to follow up on that, but you know, as I said, a wide variety of models could be built for CogNarr. A wide variety of active inference models could be built for CogNarr. But I think it would be useful to think of this as a potential playground for active inference models, because it would be a setup that would allow all kinds of you know, variations of models to test out in you know, in various, you know, levels of complexity of, you know, stories, simple stories, complex stories, and big groups, little groups, and all kinds of things. So please continue. Sorry.
Yeah, for sure. So I missed the beginning part, and maybe you have covered this, but what exactly is CogNarr? Like, is this a group of researchers? Is it just you? Like,
it's just me in the moment, and you're welcome. You're welcome to join. But it's just the two papers that I published that kind of give the broad picture of what it could be. But CogNarr itself is conceived to be an online ecosystem of tools, services, you know, software, you know, computational services, things like that. Yeah.
Okay, cool. Thank you. Just before I hand it over to Carl, if there are no more questions from the audience, do you have any questions that you would like to ask all of us in terms of specific feedback that we could provide, or anything?
No real specific questions, although I think it's among the, can you still see my screen? Is my screen still up? Yeah. I mean, Mala, as I said, Mala has done quite several papers now on topics of power, autonomy, sustainability, agency, well-being. So these are all interesting topics to me, especially in the CogNarr setting, and I think perhaps of interest to the active inference community too. But beyond these topics, there's the general topic of how would you score, or, you know, what kind of metric could be used to determine whether some process that a group is going through is either functional or dysfunctional. Like what are, that's not in this little list in my last sentence here, but it's an interesting topic of what would active inference, how would it weigh in on the topic of dysfunctional versus functional cognition? How might that be, implemented?
Yeah. Okay. Okay. Wonderful. Thank you. Okay, so I don't see any other hands raised, so I will hand it over to Carl now to provide some summary and some feedback if he has any.
Thank you. Is it my turn now?
It is. Thank you.
Well, thank you again, John. That was a laudable and challenging endeavour. I'm getting the impression in your presentation answers to questions that at this stage it's very aspirational, and if it can be done, that would be marvellous. But there are many proofs of principles and principles that need to be contended with over the years to come. So it's in terms of feedback, I'm just thinking about what would practically help, and I suspect that you have very clear in your mind exactly what this entails and what it offers. I'm just trying to think of ways of communicating that to people in other disciplines, and one thing that comes to mind is really to provide the mechanics of and possibly software tools and applications, or a tech that would enable people to find common ground. And I'm thinking about ways in which you could demonstrate that this was feasible, with a particular focus here on the collective, federated, however you want to describe it, mutual belief updating and the communication inherent in that. That seems to be the sort of primary focus, just to get formalized and possibly in silico or possibly in a quantum computer, the condensation of some shared beliefs that are articulated in this instance in terms of a narrative, which I think is exactly the right way to go. And certainly the notion of narrative theory, is it conviction narrative theory, Tomasello's notion of common ground, it would be a very fertile literature and semantics to leverage in terms of what you want to offer. So this is not building weather forecasting systems, and furthermore, it's not trying to, it's not truth pointing. It's really consensus pointing and finding the common ground. So I think that's a really interesting challenge, and it does, I think, speak to a special aspect of belief updating, because it is about belief sharing, and belief sharing under a common narrative or a shared generative model, or as Chris Fields would say, aligning your frames of reference in a way that enables that common ground to be established and to be refined, and, as you pointed out, to grow as a record, so you have access to the legacy of the way that these narratives evolved. And again, as you were pointing out, potentially there could be millions of these around the world. And then one thinks about, how do you infer what the most appropriate narrative is to actually use and to grow and to develop for your particular application, harvesting a repertoire, a library of established narratives that are somehow, in some sense, close to the kind of narrative that your group wants to engage in. So that perspective, I think, lends itself very much to self-organization, almost of an evolutionary sort, where you're now immortalizing the phenotype of an idea, or an ideology, or a narrative, or a story, or technically a generative model that generates consequence from cause that is built together. So some people would say less about research and more about we search. So in that respect, the sort of two themes come to mind, and I just picked out a couple of papers that which you have read. So you're not going to learn anything new here, but for the remainder of the audience, I thought it might be useful just to sort of point to. So if you'll allow me just to share the screen for a second. Where are they? Yeah. So the first thing that came to mind after you mentioned the representation of the story graphs as composable and possibly commutative high-dimensional tensors, and that quantum computing might be useful. What was this notion of quantum frames of reference? So I've picked out this paper, one of a couple of papers which might be relevant in terms of probably not leveraging specifically the maths in this, but certainly appealing to the fundamental challenge at hand, which is not just to build a shared narrative, but to enable the alignment of frames of reference that permits that building. And this was basically one of the key foci of Chris's treatment of the principle of unitarity, read as an instance in the quantum information theory of the free energy principle, where the joint free energy is minimized and we're all in harmony, we can all mutually predict, and we all have this shared construct. And the challenge, of course, is to align one's frame of reference. So I'm just trying to think, he's got a nice graphic where he talks about this explicitly. No, I can't find a nice graphic. But one thing, which I think this treatment does bring to the table, is something that Jim Glazebrook emphasized in terms of treating this problem of aligning, in this instance, quantum frames of reference from the point of view of category theory. And I noticed that you also introduced applied category theory as a potential mechanics or maths that might help in this. There's a very specific form of category theory here, which was particularly apt for the problem of establishing quantum frames of reference that allows you then to say that as your group progresses in time, it can only become entangled by the principle of unitarity and converge upon a shared model of other, where the other is a bulk behind a holographic screen or a Markov blanket, depending upon whether you're in a quantum or classical regime. So this is completely above my pay grade, but it does pick out for you a particular subset of category theory that may be particularly apt for addressing this kind of problem, particularly channel theory. So channel theory of quantum reference frames that he unpacked. I think he thought he was being intuitive and accessible. I'm not sure anybody else would agree, but if you can make sense of this, then that would be marvelous. And even if you can't make sense of it, I think you can use it as an example of what could be done in applying category theory to this particular problem of finding a shared cognitive narrative, or how it, solving the problem, which is basically that alignment. And just to preempt another perspective on this issue, just to refer to Ridder's suggestion, those shared, the alignment of the quantum frames of reference in a classical setting just are getting the right likelihood mappings internally consistent for everybody, so that your beliefs, when articulated either in text or in discussion or in shouting or whatever, are enable somebody to recognize what you believed. So that can only happen if there's some alignment of or consensus between the likelihood mappings. So in MDP world, or partially observed MDP world, these would be the A tensors. So I've got some belief, I've got some narrative, and they may have dynamics in it, they may have maybe have to tell a story. But the way I articulate that story means that in its expression, in the mapping, or the morphism in category theoretic terms, between these Bayesian beliefs that constitute my narrative, that are over random variables, my ontology, when I articulate them, they now become observable outcomes. They're no longer random variables. So there has to be a morphism between my narrative and the way that it is communicated and expressed. And that mapping is just a likelihood mapping. For me to understand you, and for us to have a group discussion, you have to have the same kind of likelihood mapping, such that this word accesses this semantic representation, or this token, or this tensor, or this node in a story graph that corresponds or has some isomorphism to my story graph. So that would be. It's interesting that really picked out the importance of having that likelihood mapping as part of the communication, as part of the belief sharing, because without that you don't have this alignment that enables me to understand your what you are thinking, or indeed use in any useful way the articulation or the broadcasting of your narrative in order to shrink my uncertainty, or render or adjust or update my particular narrative. I have to be able to speak your language, which means that we have to have aligned likelihood mappings. And technically, well, we'll come to that in a second. So this might be, I repeat, may or may not be useful in terms of practically demonstrating a calculus or a maths that might underwrite the primary or the fundamental problem that needs to be dissolved in order to develop these cognitive narratives. But at least it will provide a direction of travel should somebody, a category theorist or applied category theorist, want to take it on. If you could find somebody, or if you yourself have that mathematical fluency, and I repeat, I do not, possibly Toby might, but I don't, then Chris went on again with James and Filippo in this instance, to apply this notion in the context of specifically active inference, and in particular sort of control flows, dynamics that were controllable in the sense of active inference. The interesting thing from your point of view is that this story comes in two parts. These papers come in two parts. The first one just sets up the basic ideas, and it's meant to be an intuitive one, but again, you could argue whether it is intuitive for the general reader. But the second part drills down on tensor networks, and just mathematically shows that that this quantum information theoretic approach, well, let me just read this out. Yeah. In this accompanying part 2, we show that when systems are described as executing active inference under the free energy principle, their control flow systems can always be represented as tensor networks. And we show how tensor networks as control systems can be implemented with a general framework of quantum topological neural networks, and discuss the implications of these results for modeling biological systems at multiple scales. So again, this might be useful if you understand it. I don't necessarily understand it, but I still find it interesting and useful simply because you can point to this as the right kind of maths that has to be in place should one want to choose the right maths for quantum computation. And in fact, interestingly, at the end of this particular treatment, they don't talk about quantum computation at all. They actually say that the application of quantum information theory makes perfect sense in neuromorphic computing. And in fact, we are actually doing this all the time and can do nothing else. So it provides a natural formalism to understand not specifically the alignment of reference frames, but certainly this entanglement across a Markov blanket or a holographic screen, which both separates us and joins us together. So this would be the communication portal. It would either be Microsoft Teams being basically the holographic screen through which we are reading and writing from in this particular group discussion. And on that view, there does exist a formalism that can be described in terms of quantum networks. So that would be the quantum information theoretic perspective that may or may not be relevant for quantum computing per se. I have to say, I don't think quantum computing is necessary, nor is it really going to give you what you want here. But I think the quantum information theoretic approach is the right direction of travel. And to my mind, most of the functionality and the application of things like applied category theory or this particular formalism find a natural home in discrete state space models of the kind used for Markov decision processes in active inference. The only thing you have to really worry about is whether you're talking about sort of states that are known with infinite precision, so that your tensors now become logical tensors. If you can now work with extremely high dimensional logical tensors because there's only one value per column in the tensor. So you don't have to work with very large size tensors. You just have to work with lists of where the probability mass is unity in a very large tensor. And that really finesses a lot of the computational load in dealing with tensor operations that characterize exactly the Bayesian belief updating in active inference based upon generative models that have the functional form of a partially observed Markov decision process, where the partially observed bit is finessed because once if you can assume that you have very precise beliefs, and I think in many instances you can, in the sense that the probability that I've said the word, that it doesn't have a probability distribution of other words. It's the word. So that. I think there would be a license to also think about not just a quantum information theoretic story, but also a story that you could actually demonstrate in silico using finite state machines or Markov decision processes that have logical entries. You're either off 1 or 0, basically, so distinct with one hot vectors. And of course, once you do that, you're now very close to the functional form of generative models used in natural language processing. For example, hierarchical Dirichlet models, which suggest you're on the right track, because ultimately this common ground is going to be it's in the first instance, it's going to be exclusively language based. I was just thinking you could actually have one. You could have a cognitive narrative expressed in Python, but I think in the first instance, it's going to be about language, as opposed to pictures, for example, which don't have the kind of dynamics that you would need to have a proper narrative. So. Anything that sort of ends up or points towards either natural language processing or large language models or communication, I think is probably in the right direction for what you want from these things, which means that a lot of the other directions of travel disappear, which is good because you can sort of focus on the ones that are pertinent to this particular problem. And the ones that are pertinent to this particular problem in my world are summarized in this. So really, did Ozan's work, was this predicated on this kind of belief sharing, or was it before that?
What is this kind of belief sharing?
Well, this is our federated inference paper, where we're simulating three agents who are well.
Is it the 12 questions one or something?
No, I did have that up.
Oh.
I thought it wasn't necessary. Oh no, I did. Yeah, the 12 questions one is. Well, get to. Oh, we've done this one, so we can lose this. Just for your, I think the 12 questions. This is yeah. It did occur to me that this might be an interesting read if John or anybody else hasn't read it, simply because it provides a very classical, much more natural language processing take on communication. The key point though that this paper was trying to make was that communication is quintessentially a process of uncertainty reduction, and that the only language that really matters are questions and answers. That's it. As soon as you think of language and communication as basically querying the world, where the world happens to share some common ground with you in terms of having a shared language, then that's all you need to focus on in terms of resolving uncertainty, and generalizing that notion to the story graphs that underwrite cognitive narratives. It's just basically asking the right questions in order to evince the right structure of this generative model that explains the uncertainty about the world, but the world is now just the other, or the group in question. So this is the paper really you were referring to.
Yeah.
Which is
as far as I know, like the belief sharing paper that we worked on with Ozan was more based on object finding, based off of MOAD that we created. So it was just more isolated.
Right. Yeah. So this was this is I think the paper that would be more suited to a classical rendition, and makes the points that are pertinent to the cognitive narrative approach, in the sense that what it's trying to illustrate is the emergence of these aligned frames of reference as the product of a free energy minimizing process. And specifically, I think crucially for the current conversation, the free energy minimizing process entails not just parameter learning of the A matrices, but also the very structure of the mappings themselves. So to demonstrate the emergence of a common ground, or a shared a shared frame of reference, it's not sufficient just to do lots of learning. You also have to do a bit of structure learning. So you have to have inference and learning and model selection all running at the same time, with all the members of the group talking to each other. And intuitively, what that means is that if we can find our state of under the principle of unitarity, our state of entanglement or synchronization, where we all become mutually entangled and correlated, we all understand each other, then that rests upon trying out different likelihood models until we find the way of hearing somebody else that is maximally predictable. But finding the way of hearing somebody else actually requires you to do these sort of structural manipulations to your likelihood mappings, like sort of merging and or removing redundant components. So that's the reason I put this up, just to well, first of all, this is how I would simulate a group, the emergence of a cognitive narrative of a really simple sort. But more importantly, when one does simulate this, one then demonstrates at the end the emergence of a shared likelihood mapping, but can take a long time, because we're now not talking about fast inference, or indeed relatively fast parameter learning. We're talking about a kind of structure learning that is all predicated on maximizing the mutual information, in terms of everybody converging upon the same common ground or shared narrative. So this may be practically relevant if you wanted to use to have a sort of in silico demonstration of this, or a simulation of the group discussion and the emergence of a cognitive narrative of a very simple sort, or just this is a particular mechanics that you could appeal to show that it is possible, and it really does foreground again this alignment, and again the fact that this emerges, and it speaks to John, one of your questions: how do you measure how good the cognitive narrative is? So there's a very clear answer from the point of view of the free energy principle. It's just the joint free energy or shared model evidence on intergroup exchange. So if that language, that joint, that common ground, if you like, it has the highest adaptive fitness, that is operationally described in terms of the adaptation of the transition dynamics and the likelihood mappings over the ensemble that constitute the group to fit each other. So adaptive fitness has a very particular and simple meaning. It's how well I can fit my eco niche where my eco niche just is everybody else, and in particular the observable part of that eco niche just is the shared outcome space, which I repeat would be the Microsoft Teams video monitor that we're looking at the moment, or it would be some textual social media forum, depending upon the nature of the discussion or the group exchange. And that can be quantified. So the expected free, you can quantify it and decompose the goodness of the common ground, if you like, or the cognitive narrative. If I slightly overinterpret what these agents are building beliefs about, or the story that these agents are trying to share, which is effectively mums playing hide and seek, but each member of the group can only see one part of the garden in which mum is playing hide and seek, but they can shout about when they see mum, but they don't know what the shouting means before they start. So they have to align their reference frames in order to make sense of and communicate and inherit beliefs, inherit a narrative about the game that's being played on the basis of exchange with their two sisters. And you can score the goodness of that cognitive narrative, if you like, or that shared narrative, either in terms of moment-to-moment inference or in terms of learning, but most importantly, in terms of the very structure. So this would be, if like, the metric that you'd apply to your open source cognitive narrative, versions, numbers, 1021 in Middlesex. As time went on and it was evolving with multiple users all becoming familiar with this particular and nuancing it in a way that was consistent with their particular their particular views. So the expected free energy just is the mutual information. And it's nice because you can read the mutual aspect of the information as the mutual predictability, the mutual understandability, the mutual explainability of all the group members. And there is nothing else. So the environment, the eco-niche here, the world here, is just what we share. You can nuance that and actually say, well, not only do we share each other's communications, but we also have a shared access to some exogenous data. Say the reservoir or financial markets or something. But the same rules effectively apply. But you can also simplify the problem is that the only thing I have to predict is what you say, or more specifically, you and the other members of my group. And that's it. I don't have to worry about everything else in the world. So this becomes a very specialized, a specialist cognitive narrative that is fit for purpose for this group or members like the members of this group. If that helps. So that was the answer to that question. Yeah, I don't think there's anything else in this paper. Well, you can play all sorts of games in terms of understanding this in terms of complexity and joint free energy and the like, but that was the main message. One thing which I can
just inject a question. I think that maybe, if I were to encapsulate what you were just saying there, it might be that the question, do we understand each other? Like that's essentially getting to the heart of it, isn't it? Yeah. There's a group that is sharing communication, and the question is, do we understand each other? Can we predict what each other is, either will say next or their views on some topic?
Yeah.
Is that kind of the big picture of, does that encapsulate what you had just said?
Yeah, that's what I meant by mutual predictability. Yeah. If my generative model is shared, if we have common ground in the sense that we have a shared generative model of our sensed world, and that we can broadcast and discuss through some kind of communication beliefs about that model. In that particular example, it was beliefs about states of affairs under that particular model. Then I understand you. In fact, one could argue that's the only way that I could ever understand you. It's under the assumption that you share my understanding of the world. And furthermore, this is a crucial bit about the sort of the quantum frames of reference and the likelihood mappings. I speak your language. So I understand what the words mean in relation to your posterior beliefs about the world, the contingencies, the parameters, for example, or current states of affairs in terms of the inference. Yeah, it's just mutual understanding. But the only way I can do that is if we have an aligned frame of reference and implicitly really to make, even after aligning our frames of reference, if I want to be able to predict you, then the most efficient way of doing that is basically to predict that what you are going to do next is what I am going to do next, because we share the same generative model. So we align our frames of reference, but then we also align the generative model. And once we've got there, then we understand each other, or we think we understand each other. The final point I wanted to make is just thinking about, practically, if I wanted to immortalize this kind of predictable narrative or dialogue in words that captured the common ground of a group of colloculators or users, then because I am just basically dealing with a language-based representation, I can't see why there shouldn't be any problem with using a large language model that the group trains together until it produces answers that are all mutually satisfactory. So if you think about this in terms of a server architecture as opposed to sort of node-to-node distributed architecture, what you're saying is there exists a generative model that can generate content from some narrative that is shared amongst a number of people, or this is the end point, this is the objective. So if that's true, then there must be a central, if you like, hub or repository or generative model that can indeed generate the most likely thing that members of this group will generate. So if you just took a large language model as an existence proof of this shared narrative, and then you just let the group train it for a sufficient amount of time, it will come to install what this particular group says, and you just train it in a way to maximize the predictability of what the large language model says in relation to what the group thought it was going to say. So you just keep shouting at the same large language model until no one's surprised anymore. And then that becomes, if you like, you immortalized what the narrative that this group thought was important. And then you can take it to another group, or you can put it in storage, or you can, so, I'm just wondering whether you can just leverage the fact that large language models deal exactly with the space in which these narratives live, because it is language that is communicable. And just take the idea that there exists a cognitive narrative that is common to, or could be common to, with the right technology, a group of people that now can therefore, thinking of the large language model as a universal function approximator, but specifically generating language that is understandable if they all speak the same language, using that just to install or embed or to learn what that particular cognitive. So it wouldn't be explainable, but in a sense it doesn't need to be. If coming back to that paper which Riddy was mentioning, language is just about sort of querying the world and getting an answer. If your large language model gives you the answer pertinent to your cognitive narrative or to your shared narrative, job done. The explaining has now become distributed because every user of this particular specialist large language model that is private to this group knows exactly. So now you understand the large language model, not because it has understanding, but simply because it's now come to align with you in the sense that you can now predict it and it can predict you. And therefore you can use your own belief structures to understand what the large language model is doing. But so the large language model just plays a role as a nidus or a receptacle for the shared beliefs, and then you just train it, and then you can evaluate the goodness of it by the expected free energy or the mutual information between what the members of the group would say next in answer to a question and what the large language model says. You could even ask the large language model to participate in generating the questions or generating the prompts. So what kind of prompt would a member of this group provide to you? And in that sense, you're bringing up this little conceptual baby, your large language model, together. So it will be a slow process, but it'll be a process of conversation. But conversation not just with each other, but with a common repository that would be the large language model. And I mention that because the way that you talked about high dimensional tensors, of course, implicit in the tokenization of the language is a sort of classical continuous version of tensors that's rendered discrete through softmax operators and the like. But the high dimensionality is baked into the very name of large language models. So you've got the right space of generative model or generative AI in this instance that may provide a proof of concept for say a particular user group or a special interest group. They just have and no one else is allowed to do it. So this is their cognitive narrative. This is their language model that's been carefully brought up and trained, possibly over months, if not a long time, until it has the kind of expertise and the ideology that the group commonly commit to. And then you can imagine making that open source.
Yeah, I can imagine prompting the LLM with meaning representation graphs. Like I construct a graph, like a simple graph of my story, like a flowchart of my story, but that graph is used as the inputs prompts to the LLM, and it starts its learning with a set of graphs as opposed to sentences, perhaps. Like I could explain a story in sentences, or it could explain it very succinctly in graph form, and then the LLM could be ingesting these initial graphs, and it would have a head start on its capacity to understand what the group is saying, perhaps.
Yes, no, I mean, if you could do that, that would be even closer then to making it, because if it can do that, then it can also now output the graph, and you can plug that into an active inference scheme. Yeah, so that would be amortizing, I think, a slightly deeper problem, which is the meaning graph. So yeah, if one could do that, that would be extremely useful. Yeah, I hadn't thought about that in such an ambitious way. But if that could be done, then that would certainly now allow the large language models now install the cognitive narrative to speak directly to Python to be implemented in Genius, for example.
Sorry, can you hear me?
Yes.
Okay, great. Sorry, my earphones just died. Did I miss something?
I don't know. I don't know how long you're in.
No, it just happened, but I feel like I entered silence, so I thought it was my turn to speak.
Well, yes, it probably is your turn to speak.
Serendipity. Awesome. Just great with luck today when it's going to this meeting. But yeah, thank you both, and thank you all for attending. And John, thank you so much for presenting a really cool concept. We look forward to seeing what you produce, and especially some proof of concepts. I think that's where all the dirty questions come out, and a lot more interesting questions as well. So yeah, very much looking forward to that. So thank you, everybody. Let's just have one final round of applause for everybody for the discussions and for the presentation. So thank you so much. I will upload this video or this recording of the meeting online and send the link to you as well.
Thank you. Thank you, everyone.